Okay, sir.
So you can see my graph, right?
Yes, sir.
Yes, sir.
Okay. So when we did the calculation, what we are saying basically is that for us to be able to find our cutoff frequency, which will enable us to calculate the bandwidth, find the bandwidth of the amplifier, what we have to do is that we would have to estimate the voltage gain at which the cutoff frequency can be found. So in order to find the voltage at which the cutoff frequency can be found, we multiply 0.707 by the highest voltage gain. Okay, that is why we have what you see here. Okay.
Okay.
Yes, sir.
All right. So when we did that, we got 282.8, right? We got that as the voltage gain. So we approximate that to be 280. So because we can easily identify that on the graph. So now when you take this graph, just a second. So when you take this graph, for instance, what you would find is that we have 200 here, we have 220 here, we have 240 here, 260 here, and then we have 280 here. So when you trace 280 all the way to see where it will touch the graph, it touches the graph
Yes, sir.
at this particular point, okay?
Yes, sir.
And then when you trace it to the frequency, it comes to the middle of 20 and then 25. So if you are dividing 5 by 2, it's definitely going to be what? 2.5. So when you add that 2.5 to this 20, it means that our cutoff frequency, or our FC, is going to be what? 22.5
22.5.
kilohertz.
Mm.
Do you understand?
Yes, sir.
Yes, sir.
Now, bandwidth in this case, because we don't have resonance frequency and all that, if we want to find bandwidth, here would now be what? Our FC. And this would be what? Our F, let's say F minimum or F naught. So our bandwidth is going to be FC minus what? F 0. So when you substitute that, you would get 22.5 kilohertz minus 0, because this place is 0. Okay?
Okay.
Yes, sir.
And that will give you the bandwidth of the amplifier.
We have the same 22.
Yes, because it didn't start, it started from 0. If it has started from somewhere around 5, then you would take the F naught to be 5. But because it is starting from the origin, which is 0, you would take your F naught to be equals to what? 0 hertz. Do you understand?
Yes, sir.
Yes, sir.
Because the amplification is done within this region. So basically, that is the solution for question 1.
I have a question.
Go ahead.
When we had the 0.707 times the A voltage,
Mm-hmm.
I want to ask whether that 0.70 is a constant figure.
Yes, it is a constant.
Okay. Okay, sir.
Mm. It is a constant.
Okay, sir.
All right. So that is the solution to question 1 or assignment 1.
Okay, sir.